in part C from problem 2, section 5.1. Another one where we're asked to find where the critical numbers are and where the function is increasing and decreasing. So on this one, we actually want to first take note of the fact that we do have a vertical asymptote on this function. The vertical asymptote occurs at the x value that makes the denominator 0. So that happens at -4. So just keep in mind that what that means is there cannot be a critical number there. So, and we also, when we're making our table of values for our intervals of increase, decrease, we have to make sure and include that vertical asymptote as part of the intervals. All right, so let's take the derivative of this thing. That's pretty much always the first step. So this is going to require the quotient rule. So low d high again, low x plus 4. D high, well, the derivative of the top function is just 1, so I'll just mark that. Minus high d low, so the top function times the derivative of the bottom one. Well, the derivative of the bottom one is also 1. Divide all this by the bottom function squared. Simplifying that numerator, we're going to get x plus 4 minus x, and then the minus has to distribute, so minus 3. And then this is all divided by this. So x minus x, we're going to get the x's canceling. 4 minus 3 is 1, so we're going to have 1 over x plus 4 squared. Okay, so again, remember that to find the first kind of critical number, we set the numerator to 0. Well, there's no variables up there in the numerator, so that's not going to give us any solution. If I set that denominator to 0, I'm going to find that I get x equals -4. And as we've already seen, -4 is a vertical asymptote, so that can't be considered critical. So what that tells us is that we don't have any critical numbers on this particular function. No critical numbers. Okay, so that doesn't mean that we don't have to make the table, because remember that the vertical asymptote must be included. So we make our table only including the vertical asymptote, and we just check what is the function doing on either side of this vertical asymptote. So everything else is the same. We still use our test values. We still plug these into the derivative, and we still make our conclusions based on that. So test value here, we could pick -5. Test value there, we could pick 0. 0 is always a good choice. But again, really, if we've noticed this right away, we could just take a look at this derivative and say, well, what's true about this derivative? Look at these numbers here. No matter what I plug in for x, since it's squared, well, that denominator is always going to be positive. So it doesn't really matter what interval I pick. The derivative is always positive. So I could pick -5 or 0, and they'll both give me a positive value. So what is that telling me about this function? It's always increasing, okay? So it's never decreasing. So for part B, where is this function increasing? It's increasing on the interval from -infinity. Now we can't technically include that asymptote because it's not part of the domain, so I have to go -4 and then union -4 to infinity. Where is the function decreasing? Nowhere. It's not decreasing anywhere. Okay, so that's an example of a function that has vertical asymptote and no critical numbers.